For our last example from this 11.2 section, we're going to be working problem number 52, and here's how it looks. I took the time to put it into a matrix form, and so we have that system of equations that we need to solve, and I just thought we would look at one other problem and ideally other situations that can arise. So we're focused on that matrix. One thing that I haven't done yet, which is often good to do, is to interchange rows. So what if I just took row 2 and row 1 and flipped them? Well, what would that look like? That would look like negative 1, 2, 1, 5. It would look like 2, negative 3, negative 1, 0 being next, and 3, negative 4, negative 1, 1. And you're going to be welcome to do more than one thing at the same time. I'm probably in these videos just going to model one decision at a time to just make sure that we're okay. The next thing I would do is take negative row 1. So the whole reason I switched that row is because there was already a 1 there. So if I take negative row 1, everybody's going to change signs. And I'll have a 1, a negative 2, a negative 1, and negative 5 across the top. And then these other rows staying the same, just one thing at a time. So that's what happened there to produce that next one. So for the following, we could take and use row 1 to clear out the next two rows. That is a common thing to do. So let's go ahead and take negative 2 times row 1 and add it to row 2 to produce a new row 2. We'll do that in blue, right? We'll write that new row in blue. And what if at the same time, I'm debating, about doing something else. What if I at the same time use row 1 to clear out row 3? Right, and get a 0 there. Let's see what that looks like. Let's model doing two things at the same time, even though I said I wasn't going to do that about 2 seconds ago. As I think about that, that's what typically happens, right? And so the trick is to keep everything straight. So what we're not changing in either one of these is row 1. That's going to stay the same. But take a look. If we were to do the negative 2 times row 1 plus row 2, what would we get? And so we're going to get, well, negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 2 is 4 plus 3 is 1. Negative 2 times negative 1 is 2 minus 1 is 1. And negative 2 times negative 5 is positive 10 plus 0 is 10. And we get a nice kind of row coming out. What's super nice is that we got the 1 for free. That's unexpected, but that happens sometimes. Wasn't naturally going to happen, but what we did expect is to get that 0. So now if we do negative 3 times row 1 and add it to row 3, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 3 times negative 2 is positive 6 minus 4 is 2. Negative 3 times negative 1 is 3, minus 1 is 2. And negative 3 times negative 5 is positive 15 plus 1 is 16. And so we end up with these two new rows coming out. Well, you know what we're going to do next. We're going to use row 2 to clear out row 3 because we need that 0 underneath. So let's take what would it be? Negative 2 times row 2 and add it to row 3 to produce a new row 3. Well, look what happens there. We're going to have 1, negative 2, negative 1, negative 5 staying. 0, 1, 1, 10 staying. We like those. But now we're going to take negative 2 times 0 and add it to 0 to get 0. Negative 2 times 1 is negative 2. Plus 2 is 0. That's why we did it. But we're also going to get a 0 here for the same reason. And negative 2 times 10 is negative 20. Plus 16 is negative 4. And take a look what we have. We have a row that has lots of zeros in it. What we have in that last equation is 0 equals negative 4. We have an inconsistent system then. and we can stop. There's no solution coming out of this. Because the only way it would is if 0 could equal -4, and it can't. So that's how a no solution is going to work out, just in the process of getting those 1's along the main diagonal.